Now that you've created your table, take a moment to view my table and see if you missed any of them. You can see as our trains get longer, the more rod options that we have to create them. We now can partition all of the numbers 1 through 10 in a variety of different ways. Now that was just using 2 rods. If we were able to maybe use 3 or 4 rods, we would be able to partition them in much more ways. How many ways can you make the yellow rod? If I didn't give you an option on how many rods you could use, we could probably make the yellow rod in many different ways. Even further, thinking about the orange rod. If I didn't give you a limit on the number of rods you could use, we could certainly create the orange rod in many different ways as well. This helps to show the different number family relationships by allowing students to partition numbers visually. Further, knowing that we can put rods end to end with each other, we are able to partition numbers even larger than 10. Two rods put together end to end make a blue. One of them is yellow. Which one is missing? Take a moment and see if you can figure this one out. So 2 rods make a blue and one of them is yellow. So I put the blue down together. Then I put the yellow rod on top since I know that one of them has to be yellow. And then I see that the purple one would be able to fit in between. Moving to our part whole, I have 5 plus what is 9, and then using an equation, which obviously second grade is not where we're doing algebra, but ideally we're just not calling it algebra. So by putting the purple rod into 4 there, I can see that I've made a true statement. Which rod is 3 times longer than a red rod? It's 3 times longer than a red rod. Taking my red rod and putting it end to end 3 times, I see that's exactly the same length as a dark green rod. Which rod is 3 times longer than a green rod? Putting my green rod end to end 3 times, I see that's equivalent to a blue rod. Which rod is 3 times longer than the white rod? Putting my right rod end to end 3 times, I see that's equivalent to the green rod. We have seen the following concepts developed using Cuisenaire rods: number sense, part whole, patterns, skip counting, multiplication, which leads to division, multiples, and even factors.